The Amazon Web Services global infrastructure consists of more than 200 IT services that are available in the cloud. This is kind of like having a catalog of IT services available on premises. The difference is that it's accessible over a network, over the internet, for example, and it's housed on somebody else's equipment. That would be Amazon's. And so Amazon then is responsible for that equipment, for the hardware, and to a degree for the software running on it that allows these cloud services to be available to you and I, AWS cloud customers. This also means we've got scalable infrastructure available. Amazon ensures that there is a lot of equipment in their data centers to handle any requirements. And that's one of the cloud computing characteristics, isn't it? Rapid elasticity. If we need to add additional cloud storage, add additional virtual machines in the cloud, or scale up a web application load balancer to support more concurrent users, we can do that literally in a matter of seconds. And you can also scale in or scale down when you don't need as much compute power or you don't need as many virtual machines to save on costs. That also lends itself to being reliable. The global infrastructure means there are points of presence all over the world. There are data centers everywhere, and you can split up or configure some of your AWS services to run across these regions or even across availability zones. And we'll talk about regions and availability zones shortly. One of the considerations when using the AWS global infrastructure is network latency. Do we have a quick enough network connection to talk to AWS services effectively? And that will vary from one service to another and how organizations use it. But even if network latency is an issue, there are some AWS services that can run on the network edge. In other words, there are some things that you can run on premises for quick access for local users and local services, where the backend, for example, might store files in the cloud when it comes to file storage. The AWS global infrastructure is also secure at the network level with HTTPS connectivity to all services and even the option of setting up VPN connections directly into the AWS cloud through an encrypted VPN tunnel. For data stored in the cloud or data at rest, encryption is available too, for example, at the database replica level as well as at the S3 bucket level. Pictured on the screen, we have an international map of AWS global infrastructure locations. The legend is telling us that the blue dots are where Amazon will be opening regions soon, whereas the orange dot represents current regions. This is not a complete diagram because it's always changing. For example, at this time, Amazon has approximately 26 geographic regions around the world and approximately 84 availability zones. The availability zone, or the AZ, really references one or more data centers within a region. But this is constantly changing. Amazon is continually growing their AWS business and thus adding more data centers around the world. Speaking of AWS data centers, this of course is where the actual computing equipment, the storage arrays, the backup units, the servers, the network switches, network routers, all of that stuff is housed in a data center somewhere. But then we have HVAC, heating, ventilation, and air conditioning. This is an important part of the construction of a data center. For example, we might launch an EC2 Linux instance in the AWS cloud in a given region. Well, that's running on a physical hypervisor server in a data center somewhere. And that equipment needs to be kept reasonably cool so it runs at peak efficiency. And depending on the cooling system, that might require water coming into the data center, certainly electricity or power, and redundant network connections, large internet pipes into and out of data centers. Data centers are physical buildings, and so as a result, there needs to be physical security where that equipment is housed. Things like security guards, perimeter fencing, security cameras, requiring anyone entering the facility to authenticate with two-factor physical authentication, maybe fingerprint scanning and the possession of some kind of a token device, and then restricted access to the building itself, to rooms within the building, even to individual equipment racks, so that only authorized personnel can access them. Now, there are some things that are kept kind of secret. Usually, an AWS data center is an unmarked building, a big building that looks like it might be part of a military installation due to the guards and the perimeter fencing. So the locations, the details of their construction, the equipment being used in them, the storage media, destruction techniques, all of these things are not readily made available for security reasons. If you've never checked out YouTube for data center tours for Amazon AWS data centers, you should check it out sometime. They're quite fascinating. Amazon has gone so far with their data centers to even get to the point where they are using reclaimed water where possible for things like cooling instead of precious drinking water. They are even developing their own power substations and water treatment facilities. That's the scale that we are talking about with AWS data centers. It's not a small business, it's enormous. So we've mentioned that currently there are approximately 26 regions, but that's changing all of the time, and there are 84 availability zones. Remember that each region is isolated from other AWS regions, and also that each region consists of at least 2 or 3 availability zones or data centers. And when you're configuring application resiliency, you can actually split it up across availability zones so that an equipment rack failure in a data center or even a data center failure won't necessarily mean that your application goes down. But we'll focus on disaster recovery and resiliency and high availability later on. Then there's AWS network connectivity. We've mentioned that we can use VPN connections over the internet into the AWS cloud for individual user devices or for an entire on-premises network in the form of a site-to-site VPN. You would do that so you have an encrypted tunnel to the AWS cloud, which would also allow you to access things like EC2 instances, virtual machines, by their private IP addresses. You could also use a direct connect private dedicated network circuit. This is a wide area network circuit that allows you to gain access into the AWS cloud without traversing the standard internet. And of course, Amazon data centers are linked together within a region using high-speed fiber network backbones that are at least 100 gigabit Ethernet connections. So when thinking about how Amazon Web Services can meet business needs and solve problems, it's important to understand the overall global infrastructure, especially if you're a larger organization or a government agency.